In the last video, I have told you what is work function. So it is the minimum energy required for an electron to comes out of a metallic surface. Now that value will be different for different material. So for cesium, it is 2.14 and the unit is electron volt. So you should know the conversion of electron volt into joule. We know the equation work is equal to Q into V. Now if it is 5 electron, if you are using Q as 5 and voltage V measured in volt, then this will be electron volt. Okay, so 5 E is the charge of 5 electron and let's say the potential difference is 1 volt. Now the unit will be 5 eV. This is called as electron volt. Okay, now how to convert electron volt into joules? By substituting the value of E. What is E? 1.6 into 10 power minus 19. So this many joules. So electron volt can be converted into joule by just substituting the value of E and multiplying with electron volt. So value of E is 1.6 into 10 power minus 19 coulombs, and that when we are substituting with this, then we will be getting joules. But if you are substituting Q as in terms of E coulombs, that is 1.6 into 10 power minus 19 coulomb, instead of this, if you are substituting it as E coulombs, we will be getting the units in electron volt. 5 electron volt means here 5 electrons it is, so 5 E. Now instead of electrons, if you are converting it as 1.6 into 10 power minus 19, the value will be measured in joules. So simply 1 electron volt is equal to 1.6 into 10 power minus 19 joule. So this can be used for the conversion of electron volt to joule and joule to electron volt. Okay. Now cesium is having 2.14 EV, potassium 2.3, sodium 2.75, 3.2 and 4.17. Now we know that out of all the material, cesium will be giving the electron first, because see, the cesium has got a very less value for work function, which means a radiation having an energy of 2.14 electron volt can take an electron out from cesium, but this cannot take an electron out from potassium because this need 2.3 electron volt. So 2.14 is not sufficient. Now if I am irradiating a surface with a radiation having 2.3 electron volt, then potassium will also emit electrons and cesium will also emit electrons, but sodium not, because this is not sufficient to cover this. Now when this radiation is incident on potassium, this electron will have zero velocity because the whole energy is used. But here if you are irradiating a cesium surface with a radiation having 2.3 electron volt, that electron will carry certain additional kinetic energy, because out of 2.3 electron volt, this much energy of incoming radiation, this much will be used for as work function and the remaining will be given as the kinetic energy. Now one more example. Now I am irradiating a surface of this with 3.2 electron volt. Now this radiation will be able to take electron out of this, but this electron will carry zero energy, because what is remaining from this? 3.2 comes out of 3.2 is used as work function, the remaining is zero. But the same radiation, if I am giving it for cesium metallic surface, then out of 3.2, 2.14 will be used as work function. The remaining will be there with the electron and that will be the kinetic energy. Okay, so this equation we will go in detail in the coming videos. Okay, thank you.